How do we uncover the secrets of our ancient past with modern technology? Well, today I want to dive into this fascinating intersection of archaeology and AI. I want to learn more about groundbreaking research that has utilised AI to detect traces of ancient fire use in archaeological context and push the boundaries of what we know about early human innovation. And I want to learn more about some remarkable findings, how their interdisciplinary approach is transforming our understanding of human evolution, and ponder the future potential of combining AI with archaeological data. We're currently producing something like 30 to 35 episodes every single month, reaching around about 130 to 140,000 listeners around the world. So I wanted to mention the sponsor of Tech Talks Daily and also shine a light on how legacy managed file transfer tools are dated and lack the security that today's remote workforce demands. And companies that continue relying on that outdated technology put their sensitive data at risk. But the good news is you can ensure top-tier security with Kiteworks MFT Suite. Their software security hardening includes an ongoing bounty program, regular penetration testing to minimize vulnerabilities, the convenience of a one-click appliance update, and avoid the hassle of managing multiple unhardened servers. And as an ex-IT guy, I know the benefits of that. So step into the future of secure managed file transfer with Kiteworks by visiting kiteworks.com to get started. That's kiteworks.com to get started today. But enough rambling from me. Let's get today's guest on. So buckle up and hold on tight as I beam your ears all the way to Israel, where we're going to try and uncover the hidden stories of our ancestors using AI. So a massive warm welcome to the show. Can you tell everyone listening a little about who you are and what you do? And Filipe, I'll let you go first.
Yeah, okay, thank you. So I was born in Portugal. I'm a weird chemist, meaning that I'm interested in chemistry, biochemistry, material sciences, and more recently in archaeology. Well, I always am to answer this question using scientific tools to try to answer some big questions. And so I'm a chemist, and I'm a principal investigator at the Weizmann Institute of Science in Israel.
Fantastic. And obviously we've got not one but two guests. Ido, could you tell everyone listening a little about you too?
Yeah, so I'm local. I was born in Israel, yes, but I did my PhD here at Weizmann Institute in computational physics and chemistry. And in the past years of my PhD, I found a huge interest of AI, and I break into it independently. Then I got a good offer from the Life Sciences core facilities to join with AI researcher, and I'm working at the bioinformatics unit at the Life Sciences core facilities in the past 6 years on projects, mainly in medicine and bioimaging and computer vision related, but not only. Like this project with Filipe was a great project.
Well, it is such a pleasure to speak with you both. One of the reasons I invited you on here, I was reading a 2-year-old article about how you were using AI in archaeology, and this immediately set off a few fireworks in my head because I've always been fascinated by how technology is transforming our lives here in the present and in the future. But I'd not actually thought about how it can transform the world of archaeology and how we view the past. So I've got to ask, though, what was it that inspired you to combine AI and to search for non-visual traces of fire in archaeological context? What was it that made you turn to AI?
So it was proven that visual traces are not enough to find traces of fire. Actually, Filipe had a lot of data, and in this data there are hidden patterns. And the best method for this is AI, because AI find complex pattern in data that can correlate with the fire on this point with the temperature, with the heated temperature of means. Yes, so it is ideal to find these patterns. It is the best method to analyze all these huge data. Really.
If I can add something. Well, one of the things that was mentioned before is that we don't correlate archaeology because it's a social science with the technology, which is technology oriented by people. So we always forget that part of the equation, that people are always involved in both of the cases. Now, one of the things that people tend to forget because it's a social science and they don't have money, and the vision that we have is a type of Indiana Jones going in the Middle East with a whip and so on and so forth. So it's not that image, but it's when you look at it and you look at the AI, what people are looking for when you develop methods in AI, you need data. So we are talking about probably millions of years of cultural material that has been produced. And what else? You go to a museum and you have hundreds of thousands of things that have been generated by humans throughout this time. So you have large databases that you can use. The question is, how can you use them? So archaeology has the potential because he has the data set, a large data set. Then come different challenges we will address later on. But there's a huge data set and can give a lot of information about material culture and even up to a certain extent about behavior of people, how people were deciding, making decisions, why this culture took this sort of pattern and behavior versus that one. So there's a huge potential because there's a lot of data, which is what we're looking at. We're generating data every day to feed GPT and so on. So the database is there, technology is there, and people are there in that equation that we tend to forget. So it's not that very different from the ones that were in the past versus the one that we have present. And it should look closer to what we're adding to the future. Regarding also the why fire, and then you look at and think, well, the reason of fire is that was one of the very few breakthroughs in human evolution. And there's an hypothesis called the cooking hypothesis that said about when human transit from habilis to Homo erectus based on bones, that they've changed the biochemistry. So the bones were bigger and so on. So they came up with formulating this idea that about 2 million years ago, we start making fire, and fire allow us to eat, because the fire, what does, it just chocks the molecules into small digestible elements, which that's what we do. And people actually tried to do experiments with raw footage. That's what they call them. And so there is this theory that says that the cooking hypothesis is what made us humans, because men were able, or humans, or genus Homo, were able to handle fire and to control fire up to a certain point, and then cook their meat, and so that allowed them to have larger energetic intake. So, and then they would be less dependent. Imagine a panda that is always eating leaves. So it needs to constantly be eating because the nutritional value of those bamboo leaves are very low. So he just keeps eating for this large body. If you would have eaten cooked bamboo leaves, probably you would have a space of 3 hours in between eating them. So it's a bit far-fetched comparison, but still gives you the idea of what that means of having cooking food. So that allow people to move away from the center of the food and from the trees, and thus start exploring. And that developed not only the bones and the structure, but also the brain and the cognitive and spatial recognition patterns so people could walk and explore and start hunting. So they gave them freedom, so to say. And there's no technology for it to prove or disprove this theory, because it's 2 million years ago and everything is perishable. Every organic is perishable, so you don't find any source of carbon or anything. But rocks, they've been around for millions of years, and those can act as proxies for us to detect the fire mark on the rocks. So that's kind of the idea behind it.
And that's one of the reasons I invited you on the podcast today, because if we look forward into the future, there's a lot of talk at the moment that AI needs data, and we're almost running out of data as we're racing towards the future. But you guys have got a very different problem. You've got hundreds of millions of years of data that AI can bring to life, which is just mind-blowing to me. So can you elaborate on some of the specific AI techniques that you employ to detect things like the ancient use of fire, and how do these techniques differ from, let's say, the traditional archaeological methods and that Indiana Jones figure that people might have in their head?
So yes, actually we wanted to take a flint or a rock and estimate the temperature the rock heated to, or the archaeological tool, yes. So what we need a model that, yes, what we did, we used, but yeah, this is like the flint test, and actually we use spectroscopy, yes, to take a fingerprint from this flint. So we use specifically Raman spectroscopy, and you have a signal. The signal contains the fingerprint of this flint. Now there are flint that was needed for many range of temperatures, and this is in the hidden patterns of this signal, the signal that we get in Raman spectroscopy. And so basically we need a method that make between the signal to the temperature model, take as input the signal and return the heated temperature of the flint. So I will say something about this. We tried a few machine learning. It wasn't work well enough,
Yeah.
And that's actually a huge product of deep learning methods in the last 10, 15 years. You can apply deep learning. And why deep? Because learning deep, it learn one deep, let's say, deep feature, it learns insights from the signal, yes? And basically we use deep learning methods, models like artificial neural networks, and it gives much better results than the traditional material models. From the modeling point of view, it's all part of the breakthrough. Actually, using the deep learning machine learning models. Another aspect is that this model we had to do process the Raman spectral quickly. And actually, you need exactly what are the steps and what to do in order that you get optimal results. Optimal accuracy. I think Filipe, it is different from the traditional archaeology, because traditional archaeology rely mostly on visual inspection and also hard thresholding for signal, right?
Yeah. So yeah, exactly. So that's there's several problems there with the traditional archaeology, and there will be this eternal fight between social sciences and natural science, whatever you want to categorize them. It's not the discussion of the thing right here today, but for the sake of simplicity, let's keep it this way. But what the traditional, they still rely on, or some people are reluctant to use certain data. So it's very difficult sometimes to analyze human behavior based on just a few measurements. And so in that case, the traditional archaeology is very focused on dating, like dating a specific site. This is 14,000 and so on and so forth to rebuild the history. All are about very visual, but at the same, very subjective. So I don't think that this AI is going to take some subjectivity out of the interpretation, but still, it's still very subjective because we're talking about humans and based on technology. We're not looking at technology. We're using technology as something to understand human behavior. But the traditional archaeology, we feel that, first of all, there's a huge amount of data, but there's not so much people going from computer to archaeology.
Yeah.
And that's the first step. We need more people that, for obvious reasons, you can get hired in whatever company, sophisticated technology-driven company, while probably no university or even any company will hire you to do AI in archaeology. So in that case, we're very fortunate to be at the Weizmann Institute because it allows us to do all the freedom of expression, scientific freedom that we could have. And that it's not that people are convinced with AI. So there's still people using there's still the same traditional archaeological methods. What we put forward is just another method that would have more data, which I have a friend that once said that it's a world of probabilities. Right, when talking about human behavior. So what we did with AI, we just reduced like that by 2%. So it's not that it's going to solve it. Said, oh, they did this. They were making fire. No, they most likely were doing fire, and that was always in the fantasy world that we kind of So we shouldn't push the boundaries, but the traditional technologies, the archaeology are still very subjective, and that's what we're trying to balance.
Love it. And what would you say were the biggest challenges that you faced when developing and implementing your AI model for archaeology, and anything you can share on how you overcome some of those challenges as well?
First of all, we didn't know what we were doing. Very honestly, because there was nothing that we could guide ourselves on. It was,
actually during this work and developing their own AI model, exactly what we were doing here being right. Because
the main we knew. The chemistry we knew. We just don't know where we were heading.
So, I think that there are two challenges. Yes, for my purpose in this, one challenge is to get something accurate enough in the detecting purpose. And this is, you overcome this by doing all the process theory. They found the best. Okay. This was the first challenge. The second challenge is when you do this, you have a data and it is working on your data. But the great challenge also, especially in archaeology, we need a validation experiment. We need to test it against new data, another data, say, that recorded or took different time and different, let's say, even different regions or others. So this is the second challenge, that we can generalize to new data, processing data. Yes.
Yeah.
And actually, the way we deal with it is just to try to eliminate any bias, and that we can enter to the modeling pipeline and correct the validation test during the development of the AI approach.
Yeah, I will even add two small things to challenges. One is that once we get the data, we cannot ask the people anymore because they're not here. So, did you do that? No. Silence, radio silence. Okay, that's it. So that's one of the things. And that actually brings to the other question about that's the math and the chemistry. We got it all right. Probably the archaeology as well. But the big question is, once it's about the interpretation of the data, meaning that it has to do with human behavior. So we're trying to use mathematical models and chemistry, both combined material sciences, to try to explore some sort of human behavior, or and especially file related. Now, if the models that we can have the data, that if the model will tell us, listen, this is how it works, and it's with what the archaeologists they think it is, then it's fine. And they will come to us and say, why are you spending so much resources to do something that we already know? But then if it doesn't match what they say, then how do we figure that out? So it's some sort of paradox that how do we going to validate an experiment of people that are not there anymore, and there's no other more elements that we can use to validate them? So we kind of get into this crazy loop of how to validate the data mathematically. We need accuracy, we need precision, but from the human behavior becomes a very big challenge. And that's what I think the ceiling of the boundaries of AI is not anymore to make an app that you can take a picture and say, it's Ming pottery from the whatever century it was. That is not the question anymore. I think the question there for the future of AI is really how can we validate? Because you put that thing on a car, you bump the car, it has an accident, and you retrain the model and you do it again. So you have a permanent feedback of validation. Over there, it's open in the air. So that's kind of, until we solve that problem, I think we can do many interesting things, but that is a very fundamental core question in AI and archaeology, to my mind.
And I'm curious, if we just put the technology to one side for a moment and AI, how did your interdisciplinary team dynamics, how did that contribute to the success of your research? And are there any particular memorable moments from your collaboration? I'm sure you've come back with more than a few stories, but anything you can share around that?
So I think one of the most memorable moments is okay, let's do this. And then reaching out to Ido and said, yeah, why not? Let's do this. It's okay, let's do this. And then the second is okay, what do you need? I need this, and then this. And then he writes me an email, said, Filipe, can I come to your office? Of course, let's go and meet. And he shows me, Filipe, it works. And that was the wow moment that every scientist is looking for. It was like, oh no, okay, we have something big coming up. And that's for me, and the rest was technical challenges that we had to overcome. But that was the moment we said, we have something in our hands that is worthwhile exploring.
This is one of my great memorable moments, the famous minute. It is the case of the answer is identical, but I have another memorable great moment. It is when we have the first paper on Qesem Cave. It was new. It was on review. And it knew that we have to pay the validation explanation. So actually, it was a matter to get this dataset forward, and then you use this dataset, you can do nothing. So just put adding in the cloud plan and get, and was this done ironic. Then there is one moment that you feel the failure, and you understand that it is actually working on innovate. So this was another great moment for me to see that it can generalize, we can remove the model and use it on the program. This was, and I will come back to your first part of your questions about the dynamics.
Yeah.
Actually, the dynamics was great and still great. It's why we are not together. Yes. And it contributed a lot to the success of the project. Everyone of us gave more than 100% of the project, and it was.
Yeah. And I think that my experience of working at the interfaces, and I've worked in many different interfaces with architects and with companies and so on and so forth. At the end of the day, what is really important is that people know how to communicate and how to behave, and take the other side. It's like a sort of relation that you need to create, a sort of communication with friends. And so that's when the dynamics is like, okay, this doesn't work. What can we do? Oh, okay, let's think about this all together. And because it's uncharted territory, it makes it even more fun. It's like, okay, is this not working? Wow, cool. Okay, instead of like being depressed, like, oh, we've invested so much time and so on. We had the freedom because we're not on the spotlight. Nobody knew how to do this. We didn't know how to do this. So the exploratory thing was very exciting and also promoted the motivation and dynamics of the team. Right? Like, what are we going to do next? I have no idea. Okay, let's think about this and come back next week. So this dynamic was not based on any of the grant proposal pressure or anything. We had this freedom to do anything because we knew that nobody else was doing it. But at least nothing was published. We didn't know that. And that created a certain very freestyle dynamic of constructive and thoughtful and constructive, like our science should progress. Not too slow, but constructive in a constructive manner.
And for anybody that missed the article that I was talking about at the beginning of this episode, can you just explain the significance of the findings at the Evron quarry and how they compare to other known evidence of early fire use? Just to bring that to life for people listening, hearing about it for the first time and what you discovered there.
Okay, so Evron quarry is an archaeological site located at currently the state of Israel. It's located in the north, and it dates about 1 million years old. And so there were no evidence. It's probably one of the oldest archaeological sites. Probably even Homo erectus was roaming around this place. And this was discovered back in the 70s and was excavated. Now it's a dump. And so we cannot excavate that anymore. But we started this project and we thought, well, all the archaeologists said, well, you guys won't find anything, because there's no clear evidences of fire. And I thought, whoa, that's a good challenge. We've shown before that our model works, as the Ido mentioned before. So it's very generalized. We can work. The math is right. The accuracy is right. Everything looks great. Let's try another place. So we went again on this exploration. Again, it's not Indiana Jones, but it sounds like Indiana Jones type of thing. And we just started this. And actually, when we saw the results, this is another memorable moment. It was like, oh, what? There was fire. And even the archaeologists was mind blown. It's like, I don't believe this. This is impossible.
I don't know about this. It is absolutely another memorable moment. So there is fire high temperature, a panel, a quarry that we can remain quite general limit without confidence. Without this, we get the confidence because we see this was not about data memory.
And so what happens is that there are only a handful of archaeological sites with fire. Probably they're discovered once in every decade. So there are only 5 archaeological sites that do have an evidence of fire below 500,000 years. So that's basically nothing. We cannot make a serious theory because there are only evidences like red clay, something like this. So there's one charcoal about 1 million years in South Africa. There's only a handful of sites. And so what the impact that our findings were is that this is probably the second site out of Africa, what means that Homo erectus was roaming around this place out of Africa, which everybody thinks that everything started in Africa, it stayed in Africa, and then Homo sapiens came later about 200,000 in different ways. That's what all the genetics are saying and so on, through different routes. But what we say is like, not only those guys were here, they were also doing fire. So that means that either they brought it with them, sort of culture, or they were doing it local. So we don't know. That's kind of the resolution we don't have. And so that is the impact of having the second site. The other one is 500,000 in Spain, and this one is probably the oldest archaeological site that shows evidences of fire out of Africa. That's kind of what we did. Also, what it showed for us was very important, like the signal preserved in the rocks, like this one, that if you heat this, it will stay there for 1 million years. The signal on this rock. So like a timestamp or a fire stamp. And so what meant was also, listen, even if you don't have any more archaeological sites, they don't have any evidences, it doesn't mean that lack of evidence that there's no evidence of fire. So go out there and explore your archaeological sites using this technology. Probably we'll find much more. We'll start understanding the origins and the spatial temporal distribution of fire throughout. We both said, we're not the last site. This is the one that I work with. It's not known because it's one it takes. But probably the evidences of fire they have never noticed because they were just using the traditional techniques. So it opened up the doors for us to say, well, listen, you guys go out and we might find something that you're not expecting. And not only in terms of space, but also in terms of time. So you can go earlier, but you also can go lower, meaning that we can go down to 2 million or even lower to prove or disprove the cooking hypothesis. So did really cooking make us humans? So that's kind of the broad range of what the broad impact of what everyone in Quarry meant or this publication means.
And of course, that was a few years ago. And artificial intelligence now has advanced, and it's going to continue to advance. And I'm curious, how do you see AI-based methods transforming the field of archaeology in the future? And are there any other ancient human behaviours or indeed technologies that you think could benefit from this approach, that AI might be able to reveal about our history?
Actually, we use this technology we developed to understand human behavior. Okay, and actually, we very briefly we use this method, and we show that probably our ancestors before 400,000 years ago had the cognitive ability to get the correct what the temperature of the fire to heat some stones and create tools that they can use it. Yes, so we can use this technology to learn about the behavior of our ancestors.
Yes. That was crazy. That for us was like mind blowing because we are all engaged into these models and AI and what to do and what not and environment and rocks and all sorts of different things. And so when we realized that we could actually, especially on the first publication before this everyone Quarry, which is like 400,000 more than anatomical human, that we realized that they were able to heat the rocks, and then depending on the heating temperature, they were able to make one sort of tools versus another sort of tools. So basically, that's called abstract thinking. And for us, like, wait a minute, we use the AI on some rocks, and suddenly we look at human behavior, abstract thinking, meaning that you have to think in advance that if you're taking one rock like this, you're going to put it under the most likely. We're talking about likelihood of things. So you have to put it at a certain depth under the fire to actually create an environment that reaches a certain temperature so you can chip into either a blade or just a chip. And that makes a huge difference in terms of the usability of those rocks. So we could clearly see a differentiation between those types of rocks and the temperature that they were heated, meaning they wanted them to be heated. And then for us, it was like, wait a minute, can we even reach it? It's like, whoa, wait a minute. That's way too much. Lower the tone, man.
I would say that, in my opinion, this work that we understand human behavior is more complicated and more challenging, and from the application point of view.
Yes. They're different. I mean, in both cases, they have huge implications, but they were different consequences.
Yes.
Yeah. So, what we see the A-based methods. Well, I think getting to your question, I think that there's still a lot to do based on this data set in terms of the archaeology AI. Of course, there's always the app that you can have and you go to a place, and it's also very dangerous because archaeology, there's a black market going around, so you can use those apps. And we talked about this many years ago. We use this sort of apps, and we didn't decided not to, because if you have something that is worth, you think, oh, it's worth nothing, and they stole it from somewhere. They took a picture, and suddenly it's like the third or whatever. It starts worthing like millions of dollars in the black market. And so it's a dangerous zone. Not everything will be just putting a model and saying that this came from Ramses or it came from Everon Quarry or whatever. It has social implications way beyond that. So there are a lot of things that people are doing to establish patterns. I think some sort of large-scale models with a lot of data will give information about how people were handling technology and how technology evolved throughout time. Even have this crazy idea to build models that can generate future products based on ancient technology. So you could have, like, pick an iPhone or whatever phone or anything that is practical, and it also redesign that for what we've learned from. There's still a lot to learn from using AI in the archaeology, because that's the advantage of archaeology, is what we call the known of the unknowns. Because there's a large data set, but we don't know how things relate to each other because archaeology is very local. So, oh yeah, there's an archaeological site here, and I'm focusing on this. I might read something about that, but that's it. There's no correlation, and it's a continuum. Human evolution, human culture is a continuum. It's not like we stopped in one place and it got isolated. We got influences. Portuguese, they've been around because of Portuguese, Spain because of South America. Those guys have been there. They've done what they've done. So there's always an exchange of culture everywhere, and it still does, with unfortunately some situations. But this what makes human is this exchange of information that we have been doing for hundreds of thousands of years. And those patterns is something that we don't know and we would like to explore. And I think AI could play a very key role on understanding those patterns of the knowing of the unknowns.
I will add here that as you go from traditional machine learning to deep learning, and you see great improvement in accuracy, in terms of accuracy, there are results, and very nice challenge will be to develop, let's say, more sophisticated method that even give much better accuracy than in the gold state. Plus, it also depends on the quality of the data, but still moving from traditional machine learning to deep learning or reduce the error, and it will be interesting to see if those were no, even more.
Yeah. And of course, you mentioned earlier, you initially faced skepticism from archaeologists, especially regarding the potential findings at that Everon quarry. So I've got to ask, what was the most surprising discovery that your team made there? Anything that you can share around that?
Yeah, I think this method is it requires a lot of money, initial investment. And I think people couldn't believe, and they still don't, but this is always the typical resistance that you get when you approach new technologies. It doesn't matter if it's in archaeology and so on. I think that sometimes what is lacking is the math is right. So you cannot get against that. It will be very difficult to argue against the mathematical and the math behind those models, which Ido knows like perfectly all these equations, which I also follow, but is the physicist chemist, so computational. But I think it still needs some time to get more. You need to get people that do all the informatics that are interested in archaeology, and sometimes it's difficult because then what would the people do if they started working on this shit? Are they going to be hired by a big tech company? Where's the money that is given to archaeology? I'll give you an example. We do in science, in the sense of natural sciences, and we get tens of hundreds of dollars to run. That in archaeology doesn't exist. If you get $10,000, it's like a 3-year project. This is a month consumption in our lab. So you see the difference. Just to make this database was like $10,000, just to measure the Raman spectrum, the spectrum. Sorry. And so that makes it a huge difference. This barrier, this sort of, you need to have people that are interested. You need to have the resources, and you need to have the interest. So people was like, okay, I've been working, and so facing the set is like, I've been saying that this doesn't have fire for the last 20 years. Who are you to kind of tell me that this suddenly has fire based on something that I don't even understand what you're talking about? And so that is sort of the reaction we get. This is on one side from the methodology point of view. From the interpretation point of view is what I mentioned before. It's like, if it matches what people think, you're good. But it's a waste of time and money and resources. But if it doesn't match, how do you validate that? And how do you go about all the skepticism that people have? I mean, that's...
I want to add that the most of the subject discoveries, finding that we published in a bone paper in the Qesem Cave was that we talk on video on this. Most part, we are confident. There's a good confidence in this finding. So this is also the confidence in this finding.
A question I've got to ask is, if AI is able to unlock some of those patterns from our history, what implication do you think the discovery will have on our understanding of early human innovation and adaptation? And how do you think these findings could even reshape the narratives of human evolution? Is there anything that excites you here?
I think that this sort of, we've seen, I think last year, the Nobel Prize winning was on Pablo, on the genetics of the Neanderthal. I think AI has the potential to get to that stage of, it's not yet, it's still very early stages. And our contribution was a small drop on that, and showing that it works and it's able. It's still it requires a lot more momentum, more people. We get to get more people engaged from different fields to come together and talk and build those interactions and those dynamics and start pushing this area into something that we don't understand. Definitely is a very exciting way to go. We don't know where to go and what to do. Not us as our little project, but when you go large scale, we don't know what's happening. The good thing is to have momentum and people doing it, and we will walk the way. That's the exciting thing and it does have the potential to reshape what we know the same way as DNA had in the past, and like it all was published like 20 years ago, the genome. So it does have a potential. It just needs to be fully explored. Look at how everybody says like, you have a certain percentage of DNA from Neanderthals and so on, and they're talking about evolution. I think it does have this potential. It just needs time.
Yeah.
Right? That's all.
Yes. So you are about what needs to know. But the next question is related to that question. So I will go get you
And the other big question, of course, is how do you ensure reliability and accuracy of those AI-driven results? Because it is an incredibly passionate community in archaeology, especially around such complex and data-sensitive areas there. And anything that you can share around ensuring that reliability and accuracy? Is it all about the math? Because that's what people can't argue with, right?
Well, no, it's not all about that. The first stage is to get the most accurate experiments that I have.
Yeah.
If you start with something bad, or you get something bad, but the moment you have it, there are two very important steps that you can ensure reliability, and archaeology, which is related to the data, right? The first step is to design and implement the optimal component in the pipeline, okay? And the second one, to ensure that it is working, is to have a validation experiment. Because if you don't have a validation experiment, which is unrelated to the model development, it is difficult to prove confidence and that you can really know the data, okay?
Yeah.
And when you also develop the pipeline, it is very important to try to reduce any bias during this development using the appropriate validation methods and investigation methods.
What AI is also good at is bringing a lot of data which humans can't do, and so that and we taking a bit of that subjectivity, which is always associated to archaeology. I mean, people would just argue, he's an index. It's like, no, it's not. It's a chip. No, it's not the chip. Then you start, you can have several coffees sitting and talking about this, and also gives a global vision of all the data. It's not only the data that we have locally, which people will have certain tribalism as saying, well, that's my archaeological site, and that's what I know about. And so they might tend to forget the big picture. And the AI is able to bring that together and find patterns of people that they've never came up. So it might be a source of new ideas. Like, why did those guys came here? Why did Romans came to whatever? Why did they brought those certain things? So it helps to explain more now reliability and accuracy we can only apply to the map. But for the people, David Kahneman wrote this book about thinking slow, thinking fast. And we think that we cannot rely on people because we're biased. So the reliability of the word reliability and accuracy, it's good for the mathematical and that we have it right. But for the people, well, question mark.
And a question I've got to ask you both is, what future projects or areas of research are you most excited about pursuing next, particularly with that intersection of AI and archaeology? Your passion for this subject really comes to life today, and I'd be interested in what excites you both about this and where it's heading.
Okay, so as I understand, I'm really working on projects in medicine, bioimaging. I want, and actually even I plan to contribute significantly in any field that I need to improve quality of humans and to improve humanity. And maybe I cannot get into a specific project, yes, but maybe it will be in the field of medicine, bioimaging, and all of this, and healthcare. However, archaeology is very fascinating for me. It was a pleasure to work with Filipe, who will be lately joined to other projects in archaeology. And just a small point, I think it will be very nice to combine maybe images with AI images in archaeology, because images, they contain generally lower noise than data. So I think I'm going to think in this direction.
I think that there are several things, and some of them we've tried already, and we failed miserably. That's the beauty of academia. Nobody cares. We did this experiment on 2D, right? Images that were 2D. But the problem is that whenever you look at on that specific project, any sort of material is always 3D. We live on a 3D space. And so everything is 3D. So a 2D picture, takes a lot of information that is hidden, even if you take a picture like this and so on and so forth. So we had this project on cow bones and tried to look for the early stages of domestication. So we spent thousands of dollars just 3D scanning bones from crazy places like Romania and the British. We went to the London Museum of Natural History in London. We scanned dozens of bones. We spent almost 3 years cleaning up those bones from the scanning. We put them in to see whether the information that you see in 3D would give any sort of information about domestication. And we failed completely because the models were not picking up the signals. And we put 3 years just to clean the data, and then 1 year of testing, and we failed completely. And so 3D is still a challenge. It's still a challenging, normally a modern AI. 3D is important to know because all the features, because everything means something. That was chipped on a specific angle, that was folded in a specific way, because when you touch things like this, you cannot hold things the same way. And if you look at even Homo erectus and so on, that they have, the hands were different, the cognitive abilities were different, the weight, the whole thing. So it's very interesting. If you give this rock to different people, they will hold it differently. And there's a variability of information that is hidden on each chip that was removed from this. So we need information in 3D. Now, in 3D is very challenging, and you need supercomputers to train those models. So that's one thing, 3D models and 3D AI. I haven't seen anything like that, so that might be the future. Another one is cultural evolution, cultural/technology evolution, and the relation between them. So there's been fantastic work done of people that have been working on cultural evolution and so on. So one of the big things would be cultural technology, genomics, put it all together in the same package and see how things relate to each other. And there's been Nobel Prize winners and so on dedicated to one of those thoughts. We don't want infinite. But I think that combining those large data sets is what AI is really good at. And that can reshape what we know about the future. And I just gave a few examples, but it can be like hundreds of thousands more examples, because it's a very new emergent approach. Right?
I've mentioned this, maybe you can do a bunch of modality and combine them in the AI together, like images and signals.
Yeah.
And let's say start with non-stop data. And I think a lot of information can get with AI from this data, and we can use and utilize it all for the good.
For example, and there's also a technical challenge. Like, for example, we go to an archaeological site that was inhabited for hundreds of years. So how do you deal with this data? Were there some populations? What did they look like? So you have the geographical coordinates, but you have temporal resolution. Within like things like this, you can have 10 different populations in the same place, especially in the Levant. So that's kind of a very challenging system to work with. And there are many other challenges that I think once they're both some technical, others fundamental, but I think this is just the beginning of something that could be really, really big and very interesting. So we're very excited to join this from the get-go. And that was like, let's hope to see more from more people.
Yeah. Exciting times ahead. And for people listening or reading the article that will accompany this podcast episode, maybe they want to find out more information about both of you. Obviously, I will link to your LinkedIn so people can find you. Is there a website or anything that you'd like to point people to that want to find out more information?
Yeah, I can send you my website.
Perfect. Well, thank you so much for joining me today. I'm hoping we're going to ignite a conversation for once, not about looking forward, but looking backwards and what we can learn. But it'd be great to hear more about your journey as it evolves and the things that you uncover. So I'd love to get you back on maybe next year, see how things are evolving. But thanks for bringing this topic to life today. I really appreciate your time.
Thank you very much, Neil, for this great opportunity. It was a pleasure talking. Pleasure. And to have this conversation with both of you.
Yeah, no, it was a pleasure. Thank you for the invitation. And also, Thank you, Ido, for inviting me.
As we've discussed, the past has never been more accessible thanks to the integration of AI in archaeological research. And listening to my guest today, I think it challenges our assumptions about early human fire use, but also highlights the transformative potential of interdisciplinary collaboration and emerging technologies. But also gets me thinking about what other mysteries of our ancient past might be unlocked with these cutting-edge technologies. And this is the part where the microphone gets put in front of you. I'd love to hear your thoughts on the future of archaeology and AI. Please join the conversation. Share with me your insights by emailing me techblogwriter@outlook.com, Twitter, LinkedIn, Instagram, just @NeilC.Hughes. But that's it for today, so stay curious, gang. Keep exploring the intersections of technology and history. And most importantly of all, join me again tomorrow for another great guest. I'll see you all then. Bye-bye.